Hi there, and welcome to this lesson. In this lesson, we'll be learning about indices and logarithms, okay? And under indices and logarithms, we'll be learning the laws of indices. And at this point, I'd remind you to set the video to play in 1080 PhD, okay? And you can do this, so you can do that via the settings icon on the bottom right, okay? And as the lesson progresses, if you have any issues at all with anything, if anything comes off as unclear, please feel free to get in touch, okay? You can do so via the course dashboard and we would be happy to help. Okay, let's jump right into the lesson. Now, indices and logarithms, the laws of indices. Now, what are indices? Okay, what are indices? Now, indices is the plural form, okay? Basically, the singular form is an index, okay? And an index, or sometimes we call them powers, power is a number that denotes the number of times that a given number has been multiplied by itself. And I think a good number of us are familiar with this. So we have 2 to the power of 3. Now I'll tell you that 2 to the power of 3 is 8, okay? And in this case, 3 is our index. It simply tells us that we have 2 times 2 times 2, okay? So 2 times 2 times 2. And then you can have another one, 7 to the power of 5, and basically 7 to the power of 5 tells us that we have 7 times 7 times 7 times 7 times 7. Okay, let's move on. Now, there are certain laws, or there are certain operations that we perform on numbers with indices. Okay, we can multiply them, we can divide them, and but then there are laws that govern these operations. Okay, and when we're doing these operations, there are certain laws, there were certain principles that we need to follow, and that is, we would be discussing these laws in this lesson. Okay, and let's jump right into it. Now, the first law is a law governing multiplication. So this is going to teach you how to multiply indices, how to multiply numbers with indices. So let's have an example. So let's say you have 4 to the power of 2 and you want to multiply this by 4 to the power of 4. Okay, let's expand this out. You simply have 4 to the power of 2 as 4 times 4. Okay, and then you're multiplying this by 4 to the power of 4 as 4 times 4 times 4 times 4. Now, just looking at that, you can basically see that that's 4 times 4 times 4 times 4 times 4 times 4. So we have 6 fours there. Tells us that this is actually 4 to the power of 6. Let's do another one. So we have 11 to the power of 3 multiplying 11 to the power of 4. Okay, and basically what this is you have 11 times 11 times 11, that's 11 to the power of 3. I'm multiplying this by 11 times 11 times 11 times 11, i.e. 11 to the power of 4. Now, just look at that and count the 11s. You have 7 11s there, tell you that you have 11 to the power of 7. Okay, so let's identify the pattern here. So we have 4 to the power of 2 and 4 to the power of 4 equals 4 to the power of 2 plus 4, 6. Interesting. We have 11 to the power of 3 multiplied by 11 to the power of 4. We have 11 to the power of 3 plus 4, 7. This is our first law. Okay, and basically what we have is anytime you have a number to a certain index and you're multiplying it by the same number to another index, you simply have the answer as that number to the power of the sum of the indices. Okay, so if you have x to the power of a multiplied by x to the power of b, you have an answer x to the power of a plus b. You just add the indices together and it will give you the answer. Okay, now something you need to note is that the laws of indices apply when you're working with the same number. Okay, for example, you look at the first one you have there. We had 4 to the power of 2 and 4 to the power of 4. Okay, we didn't have 4 to the power of 2 and 3 to the power of something else, 3 to the power of 7. You have the same number, 4 to the power of 2, 4 to the power of 4, 11 to the power of 3, 11 to the power of 4. So the laws of indices only apply when you're working with the same number. Okay, it could be different indices, but you have to be working with the same base number. Okay, so that is the law of multiplication. Multiplication translates to addition. And then the next law we'll be talking about is law 2, is the law of division. And let's do some thinking here. If you have multiplication, the law of multiplication translates to addition. What do you think the law of division translates to? Let's find out. So we have division here, and we have 7 to the power of 5 divided by 7 to the power of 2. Okay, and basically if you expand that out, what you have is 7 times 7 times 7 times 7 times 7 divided by 7 times 7. Okay, and basically we're dealing with a fraction here, and we can simply cross the numerators and denominators. So we have 7 here 1, 7 here 1, 7 here 1, 7 here 1, and what we're left with is we have 7 times 7 times 7, and this is 7 to the power of 3. Have you noticed it? Yes, and you probably guessed it right. If multiplication translates to addition, division translates to subtraction. So pretty much anytime you have an index, a number with an index divided by the same number with another index, you simply find the difference of the indices. Okay, so this is our second law. X to the power of a divided by x to the power of b equals x to the power of a minus b. Okay, this is our second law, a law for division. Now let's go over our next law, law 3, and law 3 is zero index. Okay, zero index. And what's zero index about? Now consider this. If you have 3 to the power of 4 divided by 3 to the power of 4, okay, so just division like we just went through, basically you'd have this as 3 to the power of 4 minus 4 based on our division law. And what this is 4 minus 4 is 0, so you have 3 to the power of 0. Now let's actually expand 3 to the power of 4 divided by 3 to the power of 4. Okay, so let's work it out. Let's bring the whole thing out. So you have 3 times 3 times 3 times 3 divided by 3 times 3 times 3 times 3. And when you cross 1, cross 1, cross 1, when you cross it all out, what you end up with as your answer is 1. Okay, and what you can extract from that is that 3 to the power of 0 equals 1. Now if we perform the same operation on pretty much anything, okay, even if you have 1 million to the power of 100, all right, you will still get the answer 1. Okay, so if you had 1 million to the power of 100 divided by 1 million to the power of 100, your answer will still be 1. Okay, and let's consider 2 to the power of 5 divided by 2 to the power of 5, because when you apply the division law, you have that as 2 to the power of 0, and when you expand that out, 2 to the power of 5 is 32, so you have 32 divided by 32, and what that gives you is 1. What is the law here? Anything, absolutely anything. Sometimes you even have it in algebra, you can have y to the power of 0, it still gives you 1. Anything at all to the power of 0 is 1. Okay, and that is our third law. X to the power of 0 equals 1. Okay, let's move on. So the laws of indices, and I think we're on our fourth law now. So law 4, and law 4 is negative index. Okay, so negative index. And now let's consider this. You have 1 over 3 to the power of 2. Okay, And basically from our zero index law, we know that 1 can be written as 3 to the power of 0. So we have 3 to the power of 0 divided by 3 to the power of 2. And then if you apply our division law, you basically have 3 to the power of 0 minus 2. Okay, and 0 minus 2 is what? 3 to the power of minus 2. So 1 over 3 to the power of 2 equals 3 to the power of minus 2. What's the law here? When you have a number with an index as the denominator of a fraction, so let's say 1 over the index number, it basically equals the number with the negative version of that index, the negative form of that index. So basically, if I have 1 over 4 to the power of 5, it equals 4 to the power of minus 5. If I have 1 over 7 to the power of 10, it equals 7 to the power of minus 10. Okay, it's always 1 at the top. Okay, nothing else. All right, so anytime you have 1 over an index number, a number with an index, it equals that same number with the negative form of that index, and that is our negative index law. Okay, 1 over x to the power of a equals x to the power of minus a, or you can actually write that the other way around. You have x to the power of minus a equals 1 over x to the power of a. Okay, and that is our negative index law. Okay, so I think we have 3 more laws to get through. Let's jump right into that. Law 5. And law 5, we have double index. And this is going to come off as strange to some of us, but let's get right into it. What is double index? The double index law. And here's what it is. It's when you raise a number to one power and then you raise it again to another power. That's a double index. Okay, so and for example, in this case, we have 3 to the power of 2. We have 3 raised to the power of 2, and then we'll raise it again to the power of 3. Okay, and basically when you break this down, you simply have 3 to the power of 2 multiplied by 3 to the power of 2 multiplied by 3 to the power of 2. And if you expand this further, you have 3 times 3 multiplied by 3 times 3 multiplied by 3 times 3. And when you just looking at that, you have 3 times 3 times 3 times 3 times 3 times 3. And basically you have 3 to the power of 6. Let's try another one. Another double index. So let's say you have 7 to the power of 4 to the power of 2. Okay, and basically what this is it is 7 to the power of 4 multiplied by 7 to the power of 4. And basically when you expand this out, you have 7 times 7 times 7 times 7 multiplied by 7 times 7 times 7 times 7. And when you work this out, you have 7 times 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 7. You have 8 sevens there. This is 7 to the power of 8. Now let's identify a pattern here. We have 3 to the power of 2 to the power of 3 equals 3 to the power of 2 times 3, 6. Interesting. And then you have 7 to the power of 4 to the power of 2 equals 7 to the power of 4 times 2, 8. I think we have our law. Okay, and basically what we have is anytime you have a number x to the power of a to the power of b, it simply equals x to the power of a times b, or ab. And that is a double index law. So anytime you have one number raised to an index raised to another index, it simply equals the same number raised to the product. Basically you just multiply the two indices and you have an answer, just like you did for 3. 2 times 3, 6, or for 7, 4 times 2 is 8. And that is our double index law. Okay, so the next law we'll be learning about is our fraction index law. Okay, I think it's getting strange now. Okay, so we're going to have a fraction index. The fraction index is actually really simple. Okay, and so you have something like this. You have 4 raised to the power of 1 over 2. Now Simply put, when you have something like this, 4 raised to the power of 1 over 2, it simply means the square root of 4. Okay, 4 raised to the power of 1 over 2, and the numerator is always 1. Okay, when if you have something like 4 raised to the power of 2 over 3, it's a bit more complex than that, but then it doesn't apply quite as such. All right, so it's always 1 over something. All right, so you have 4 raised to the power of 1 over 2 simply means the square root of 4, which will give you 2. And similarly, we have 27 to the power of 1 over 3. What do you think this would give you? It will give you the third root, or the cube root of 27. This is 3. You could have 32 to the power of 1 over 5, and it will give you the fifth root of 32, which is 2. Okay, so pretty much anytime you have a number raised to a fraction index, you basically just look at the denominator there and find the root of that number based on that denominator. Okay, so our fraction index law says that if you have x to the power of 1 over a, you simply find the 8th root of x. Simple, straightforward. That is our law. Let's move on. And now finally, our last law, our seventh law, law 7, is the distributive law. Okay, and let's break this down. Now we have 3 times 2 squared. Okay, so 3 times 2 squared, and then when you work this, you're going to have 3 times 2 is 6. So we have 6 squared. And basically what we end up with is an answer 36. Now, let's assign that square to the individual numbers in the brackets. So we have 3 times 2 squared, giving us 3 squared times 2 squared. Okay, and basically 3 squared is 9. And 2 squared is 4, so you have 9 times 4. And something you notice, it gives you the same answer, 36. So what's the law here? Anytime you have two numbers in a bracket multiplying each other, raised to a power, you can actually assign, you can distribute that power. You can actually assign that power to the individual numbers in the bracket, and it will still give you the same answer. Okay, so something you need to note, okay, and I'm going to speak very slowly at this point because I need you to get this. The distributive law only applies when you're performing multiplication and division. The distributive law does not apply when you're performing addition or subtraction. For example, if we replace the multiplication sign there with an addition sign, basically we'd have 3 plus 2, which will give us 5, and you have 5 squared. The answer you'd get will be 25. And if you decide to distribute, you'd have 3 squared plus 2 squared. That will give you 9 plus 4. It will give you 15. It does not give you the same answer. So 3 plus 2 all squared does not equal 3 squared plus 2 squared. This only works for multiplication and division. Okay, so our law is that we have, if you have x multiplied by y raised to the power of a, this gives you x to the power of a multiplied by y to the power of a, and that would bring us to a conclusion, and we have our 7 laws of indices. Fantastic. So what exactly are we going to do with these laws? We're going to apply all of them to solving some examples. Example 1. Simplify 64 to the power of 2 over 3. Okay, this should be fairly easy. Now, when you're solving indices questions, they're usually not just given to you, and maybe they won't just ask you to apply a certain law. Let's say I ask you apply the multiplication law to solving this question. No, you usually need to figure out what laws to apply. That's pretty much the testy part, to test a bit with the questions. So we have 64 to the power of 2 over 3. We're obviously going to apply the fraction law, okay, at some point, because we have a fraction index in this case. And but then there's something strange about this fraction index, in that it's not 1 over something, because if it was 1 over 3, we would simply know we need to find the cube root. But then we don't have 1 over 3 here. What we have is 2 over 3. But there's something we can do, though. There's something we can do. We know that 2 over 3 is 1 over 3 multiplied by 2. Yes? Yes? Right. So 2 over 3 is 1 over 3 multiplied by 2. And we have 1 over 3 multiplied by 2. We can actually apply our double index law here. Okay? Because basically a double index says that when you have one number raised to the one power to another power, you simply multiply the power. So we can actually reverse that, and basically we have 6 to 4 to the power of 1 over 3 multiplied by 2 is the same as 64 to the power of 1 over 3 to the power of 2. And now we can work 64 to the power of 1 over 3 as the cube root of 64, or to the power of 2. And then we can have the cube root of 64 is 4, and so we have 4 to the power of 2. And now we can simplify that as 4 to the power of 2 is 4 times 4, 16. And that is our answer. Let's solve another example. So example 2, and example 2 says simplify 8 to the power of 2x plus 2 multiplied by 4 to the power of x. Okay, now we're actually working with two numbers here, and you notice something about these numbers, they're not the same. So we pretty much can't apply any laws here. Okay, so how exactly do we go about solving this? Because before we apply any laws of indices, the base number has to be the same. But in this case we have 8 and 4. So what can we do here? Something you notice is 2 is a related number here, because there's a relationship there. You just look at 8 and 4 and it rings 2. How? Because 8 is 2 to the power of 3 and 4 is 2 to the power of 2. So we can actually write this down as 2 to the power of 3 raised to the power of 2x plus 2. And we have 2 to the power of 2 raised to the power of x. So we have 2 to the power of 3 in place of 8, and we have 2 to the power of 2 in place of 4. Now, something interesting I need to point out here, we actually have x's. We've introduced x's. We're not working with numbers, but we're working with x's. And you have questions like that sometimes, okay, and basically when you solve this question out, you obviously would not end up with an answer. It's pretty much just like you have your algebra. If you have 2x plus 5x, you end up with 7x. You would not get an answer, like a number in the end. You would get an expression in terms of x. But I just have to point out that it's not strange to have questions where you're working with indices that involve x's or y's or m's or what have you. Okay, so the first thing we've done here is we've gotten an even base number, equal base number. Okay, and then from this point on, it's simply apply the different laws of indices. So obviously the first law we'll be applying here would be the double index law. So step 2, first thing we want to do here is apply the double index law, and we have 2 to the power of 3 multiplied by 2x plus 2 multiplied by 2 to the power of 2 times x, 2x. Okay, so we just multiplied the powers, and then we can work these out and basically expand those. We have 2 to the power of 6x plus 6 multiplied by 2 to the power of 2x, and what we have is 2 to the power of 6x plus 6 plus 2x, and when you work that out, you have 2 to the power of 8x plus 6, and that is pretty much your answer. Okay, so let's move on to the next example. Example 3, and example 3 says simplify 27m to the power of m plus 2 multiplied by 4 to the power of m divided by 6 to the power of 2m. Interesting. Now, something about this question is obviously we have different numbers here, but my oh my, they don't seem related in any way. Okay, no. I think I've identified something you'd have there. Okay, let's break this down. So we have 27. I know you have a 3 there, okay, because 27 is 3 to the power of 3, okay, and then there's a 4, and 4 is 2 to the power of 2. What about the 6? Let's find out. Oh, 6 is 2 times 3. Interesting. So basically, we're obviously going to be applying the last law here, the distributive law. So we have 3 to the power of 3. That's for 27. 27 is 3 to the power of 3, all to the power of m plus 2. And then we have 2 to the power of 2, all to the power of m, divided by 2 times 3 to the power of 2m. And from this point on, you just need to apply the different laws of indices. So let's start with the end. Let's start with the distributive part. So basically what we have there is we have all of that at the start, divided by 2 to the power of 2m. So we assign the power to the individual terms in the bracket. Okay, so 2 to the power of 2m multiplied by 3 to the power of 2m. And then we can get rid of the brackets, apply the division sign to both terms. So we have divided by 2 to the power of 2m divided by 3 to the power of 2m. And then I think we can go back to the front to the first two terms and then work the double powers that we have there. And then when we do that, we end up with 3 multiplied by m plus 2 and 2 multiplied by m. And then you have 3 to the power of 3m plus 6 multiplied by 2 to the power of m divided by 2 to the power of m divided by 3 to the power of 2m. Just gradually, we're just applying the laws. Okay, and at this point, what I'm going to do is I'm going to collect like terms, bring the 3's together, bring the 2's together, and basically I have 3 to the power of 3m plus 6 divided by 2m. I can apply my division law there, and I can apply the same division law to 2 to the power of 2m divided by 2 to the power of 2m. And basically what I have is a difference of the indices, and I end up with m3 to the power of m plus 6 multiplied by 2 to the power of 0. 2 to the power of 0 is what? 1. And basically we have 3 to the power of m plus 6 multiplied by 1. Anything multiplied by 1 is the same, so we have 3 to the power of m plus 6, and that is how you solve that. That's your answer, 3 to the power of m plus 6. Look how beautifully well we simplify that. So let's move on to the next question, next example. Remember, basically when you're solving questions on indices, you don't need a calculator to do this. It's actually ridiculously easy. You just need to apply the laws. Once you have the laws at the back of your mind, you look at the question and you go, which law can I apply at this point? Okay, you know everything in the back of your mind. You know that you can only work indices when you're working with the same base number, so you always try to get an even equal base number, and then from that point you go on, can I apply the double power law, the fraction law, the division law, the multiplication law, the distributive law. And once you've mastered that, you pretty much wouldn't have any problem solving questions that look like example 4. Okay, so this looks quite interesting, but then let's jump right into it. So we have 25 to the power of 2 over 3 divided by 25 to the power of 1 over 6, or divided by 1 over 5 to the power of 7 over 6, divided by 1 over 5 to the power of minus 1 over 6. Looks easy. So first thing we want to do here is we don't have equal numbers here. And the first thing we want to do is we want to have an even base number. Okay, so and if you look at this, you pretty much get the idea. You have 25, 25, 1 over 5, 1 over 5. The number is 5. Okay, so let's express all of these in terms of 5 and 5s. So 25 is 5 to the power of 2. So we have 5 to the power of 2 to the power of 2 over 3 divided by 25, 5 to the power of 2, 5 to the power of 2 to the power of 1 over 6. Let's go over to the denominators. Now 1 over 5 is the same as 1 over 5 to the power of 1. And if you remember your negative index law, you know that 1 over 5 to the power of 1 is the same as 5 to the power of minus 1. Okay, so you have 5 to the power of minus 1 multiplied by 7 over 6, okay, divided by the same 5 to the power of minus 1 raised to the power of minus 1 over 6. Now, the next thing we want to do, I think we'll just write all of that down. Okay, and the next thing we want to do now is we want to solve this using different laws of indices. And looking at it, I think the first thing we want to do here is we want to apply the double power law. Okay, and we can do that to the numerator. So we have our line, and basically 5 to the power of 2 to the power of 2 over 3 becomes 5 to the power of 2 times 2 over 3. You end up with 5 to the power of 4 over 3. Divided by 5 to the power of 2 to the power of 1 over 6 is 5 to the power of 2 times 1 over 6. What you end up with is 5 to the power of 1 over 3. And then you have 5 to the power of minus 1 to the power of 7 over 6, the same as 5 to the power of minus 1 times 7 over 6, which will give you 5 to the power of minus 7 over 6. Okay, and then you have 5 to the power of minus 1 to the power of minus 1 over 6, and basically what you have is 5 to the power of minus 1 times minus 1 over 6, and what you end up with is 1 over 6, because minus 1 times 1 over minus 1 over 6 is 1 over 6. So you have divided by 5 to the power of 1 over 6. Okay, and then when you solve that out, basically at the moment you have division, so we can apply our division law here. You'd have 5 to the power of 4 over 3 minus 1 over 3, because you have 5 to the power of 4 over 3 divided by 5 to the power of 1 over 3. You simply apply the division law and you find the difference of the powers, and basically you have that. And you do the same for the denominator. You have 5 to the power of minus 7 over 6 divided by 5 to the power of 1 over 6. This will give you 5 to the power of minus 7 over 6 minus 1 over 6. Okay, and then when you solve that out, what you have is 5 to the power of 4 over 3 minus 1 over 3 is 1. So you have 5 to the power of 1. And minus 7 over 6 minus 1 over 6 is minus 1. So you have 5 to the power of minus 1. Okay, so at this point, you just need to simplify that out. So we have step 3. 5 to the power of 1 divided by 5 to the power of minus 1 equals, using the division law, so we have 5 to the power of 1 divided by 5 to the power of minus 1. This is 5 to the power of 1 minus minus 1. Okay, it's because you find the difference. And basically what you have is you have 5 to the power of minus 2. So we have a negative index here, and we can express 5 to the power of minus 2 as 1 over 5 to the power of 2. And then what you have is 1 over 25. 5 with that, i.e. 1 over 5 squared is 1 over 25, because 5 squared is 25. And that is pretty much what you need to know about the laws of indices. Okay, so we've gone through all 7 laws and we've used them to solve 4 examples. Okay, and the idea here is, once you have the laws at the back of your mind, you look at the question, you basically just need to figure out how to apply those laws to solving the question. Okay, the first thing you need to know is you always need to work with the same base number. So usually when you look at the question, the first thing you need to do is, how do I get all those numbers to be at the same base number? And then from that point on, what law do I apply? Do I apply the double index law? Do I apply the fraction law? Do I apply the negative index law? Do I apply the distributive law, the multiplication law, or the division law? And from that point on, it's pretty much just simple arithmetic. So that would be the end. I will conclude this lesson, and then the next lesson we'll be learning about equations involving indices. Okay, so that's what we'll be doing in the next lesson, and yeah, bye for now.